Right, so welcome everyone and welcome to this new video where we discuss mathematics and physics on the board. Today what we are going to do is basically start a series of two or three videos where we discuss and derive in fact the Hodge dual of one forms, two forms and then three forms in R cross R3. So essentially this is in R4, but the reason why this notation is used is because that's the one being used usually when we want to discriminate one of the dimensions against the others. Okay, so there is application of that to special relativity and in particular to also electromagnetism as well that we'll see in a physics application later. But for the time being, we are just going to have a succession of short video where we actually discuss these things. Right, so first of all, let's set up a little bit the context and some generality. The first thing is you can check a video we've made earlier on the definition of the Hodge dual, and we also had applications in R3 for Euclidean inner product. Now, in this particular case, I'm basically summarizing all these rules. So essentially what you do is that you have a set of one forms. So a first set, U1, UK, they are one forms. And here another set, V1, VK, and again, this is another set of one forms. So you've got these sets here, and they are defined, both of them, in R cross R3, and there is a corresponding basis E0, E1, E2, E3 corresponding to them, which is kind of orthonormal and so on. Okay, so then basically we define an inner product with signature here, plus and then minus, minus, minus. Okay, so that's the signature we've chosen here. So indeed, you see that there is one that is special, that has a plus sign, and there are three that are basically different, and they have a minus sign in front of it. And then you choose or you select or you define a bilinear map that goes from essentially R4 or R cross R3 and then goes into basically R. Okay, so that's what this form is going to be, and what it takes in is actually a K form. So it takes a K form in the first slot, which is made of a product of other one forms. And in fact, here it takes in the second slot, it takes essentially a second K form that is really made of a product of one forms as well, okay, which corresponds to these two sets. And we define this particular bilinear map as being the determinant of basically a matrix which is made out of the components which are inner product of the vector ui along this thing with the vector vj corresponding to that particular side. Okay, so it's a bilinear map, and that is going to be quite useful, especially in the coming videos, to determine how these things actually goes. So once we have all of that being defined, then we have that if we have alpha and beta, which are K forms in R4, then alpha wedge, the dual, the Hodge dual of beta is by definition f of alpha beta, and then times the so-called canonical basically K form, and here there's a canonical 4 form or volume form, which is E0, E1, E2, E3. Okay, so basically that's it. And so what we are going to do is apply these general definitions to basically successive forms, one forms, two forms, and three forms. And then I think after that we should be done. So so let's move on then. So we've got k is equal to 1. So what that means is that I have alpha is going to be equal to alpha naught E naught plus alpha 1 E1 plus alpha 2 E2. Likewise, beta is beta 0 E0 plus beta 1 E1 plus beta 2. And sorry, I'm still in 3D here. So that's still fine, but I need to go to plus alpha 3 E3, beta 2 E2 plus beta 3 E3. Okay, so we are in R4, so I need to expand over all of this. And then what I'm going to say is the following. I'm going to posit that the Hodge dual of beta has to be a 3 form, and I need to simply get the right combinations. So the first thing that I'm going to say, therefore, is going to be beta tilde. So beta tilde here is my way of denoting the components of the Hodge dual. I could put the star beta, but that's just too cumbersome. So I'm just using beta tilde for the components. So that's, let's say, beta tilde, and then we are going to get, for example, 0, 1, 2, and that's E0, E1, E2, plus beta tilde, and then we simply have 1, 2, 3, and then that's E1, E2, E3, plus beta tilde, and then that's going to be E2, so that's 2, 3, 0, so that's E2, E3, E0, and then plus beta tilde, and then that's 3, 0, 1, so that's E3, E0, E1. Now, you could say, but how do you get kind of this series of combination? And that's the only ones we can have, which are not going to have a single, a vector which is the same in any of these kind of forms here. Now, the way I'm actually going there is because I simply go from so E0, E1, E2, and then I basically shift along this particular thing. So I start with this one, then I shift rightwards, so I get then 1, 2, 3, then I basically shift again rightward, so that's going to be E2, 3, and then I use cyclic permutation, so that's E0, and then I'm going to use rightward again, E3, E0, E1. Okay, so that's kind of the logic I'm using to make sure I actually get all of them. And if you actually were to shift again rightward, you would get E0, E1, E2 again. Okay, so that's kind of how I do it. And then what I'm going to do is that alpha wedge beta is going to be equal to alpha 0. Let's not go too well. It's actually quite straightforward. I can simply look at which part is missing E0 here. It's this one. This one has E0, this one has E0, this one has E0. So if you take wedge of E0 with anything with E0, it's going to get 0. So basically, the only one is going to be this one. So that's beta tilde 1, 2, 3, and then E0, wedge E1, E2, wedge E3. Then I'm going to get so alpha 1. So I need to have something without E1. So here I've got E1. Here I've got E1. Here I've got so that's the only one where it's not going to get any problems. So that's I've got alpha 1. Alpha 1 beta tilde 2, 3, 0, and that's going to be E1, wedge E2, wedge E3, wedge E0. Okay, and then we are going to have plus, so that's alpha 2. So alpha 2, we need to have something that doesn't contain E2, so that's this one. So that's beta tilde 3, 0, 1, and then that's going to be E2, wedge E3, wedge E0, wedge E1, and then plus alpha 3. And again, we need one that doesn't have, and that's E3 here, sorry. We need one that doesn't have 3, so that's this one. And so that's beta tilde 0, 1, 2, and then that's E0, E1, E2, and then no, sorry. I need to put things in the correct order. So it's going to be E3, E0, and then E1, E2. Okay, so what I want to do now is to make sure that I can get things right if I actually apply permutations, right? I want to retrieve all of these guys here. I want to put them in the form like this. So how do I do that? Well, basically, I start here, for example. So let's look at this one. So here, if I swap once, okay, these two, well, I'm not sure I want to do that, to be honest. So let's think a bit more. So what I want to do is I'm going to swap E0 with E2. Yeah, let's do that actually. So yes, let's swap E0 with E2, and that's going to bring me a minus sign. Okay, and then I swap, once I'm done with this, I swap E1 with E3. Okay, so that's what I'm going to do, and here that's what I'm going to do. I get a minus sign as well, and therefore what that means is that here, this is basically just plus E0, wedge E1, wedge E2, wedge E3. Likewise, here I've got E2, E3, so what I can do is basically swap E0 with E3. Ah, that's interesting, actually, this one. If I'm not mistaken, that's interesting. So in principle, if I'm not, so let's just be sure we got the right one. So 230, and that's E1, yes. So well, if I actually swap here first E0 with E3, I get a minus sign. Then after that, I'm going to have E3 here, but E0 there and E2 there. So then I'm going to get to have a swap here. And then here I'm going to have E0, E2, E3, so I'm almost right, and then I need to swap another time between E0 and E1. So in principle I would have another one here, which is going to give an overall minus sign. Now let's look at this one. Now this one is going to have, let's be a little bit careful. So this one is going to have, so how do we do this? So if I swap, so I can swap E3 with E2, so that's going to get a minus sign, but E2 is going to be there, okay? So then I would need to swap E2 with E1, so that's a minus sign again, and then I would have to, so that would be here E2, so that's 1, 2, and then I would have here E1 and E0, and so then I would have another minus sign here as a third step. So basically that's where we are. So there is, in the end, what we get is something like this. We get that this is alpha naught, beta tilde 1, 2, 3, and then minus alpha 1, beta tilde 2, 3, 0, then plus alpha 2, beta tilde 3, 0, 1, okay, and finally minus alpha 3, beta tilde 0, 1, 2. Okay. Now, finally, what we need to do is to compare this particular expression, which is going to be in the form E0, E1, E2, E3. And I want to compare that to f of alpha beta. Now, because alpha and beta are one forms, the only thing we need to do, so that's E naught, E1, E2, E3, is basically just to apply the inner product. So that's going to be alpha, beta, and then E naught, E1, E2, E3, and that's going to give alpha 0, beta 0 minus alpha 1, beta 1 minus alpha 2, beta 2 minus alpha 3, beta 3, E naught, E1, E2, E3. And that's supposed to be true for any kind of alpha and beta here, so that's supposed to be very general. And so what we get out of this is basically by comparison, I'm going to get that beta 0, so beta tilde 1, 2, 3 is equal to beta 0. Then I'm going to get that minus beta tilde 2, 3, 0 is equal to minus beta 1. Then I'm going to get that beta tilde 3, 0, 1 is equal to minus beta 2. And then we have finally that minus beta tilde 0, 1, 2 is equal to minus beta 3. Okay, so it's kind of a weird kind of mix because of the different permutation relations you have here. Then you don't necessarily get kind of always the same quantities. So for example, let's say that beta is equal to E0. Then from what is written here, we are going to get, so beta 0 is 1, and then beta 1, beta 2, beta 3 are 0. So consequently, we are going to get that beta, which is star E0, is going to be equal to, what was it? Yeah, so to E1, E2, E3. Okay, but then if we take beta is equal to E1, then we've got that this is equal to star of E1. And what we have is that essentially this beta, the Hodge dual is a form, and this is going to have that this is E2, E3, E0. Then if beta is equal to E2, then the corresponding Hodge dual is equal to, in that particular case, we have beta 2, so that's going to be minus, because there is a minus sign here, so that's minus E3, E0, E1, and then beta here is going to be, so if this is equal to E3, we've got that the wedge, so Hodge dual is equal to star E3, and that's going to be plus, in that case, E0, E1, E2. So we see here that the actual duality, or the way the Hodge duality works in this very specific case, where not only we've got this particular inner product, but also the number of permutations we've got to make actually gives rise to various minus signs. It essentially kind of leads to various problems and so on. So basically, part of it has to do with the fact that you've got 3 wedges here, and that's what you get. That's where you get this. So that's where we are when it comes to one forms, and basically in the next video we'll see how that goes with 2 forms.